Let's take a look at multiplying radicals. Let's take a look at this problem. We got the square root of 5 times the square root of 20. Well, when your indexes are the same, then you can multiply what's underneath the radicals and put them underneath a single radical. So we'll have square root of 5 times 20. Now we don't actually multiply them together because we're going to see if something will simplify. Let's look at the 20. I'll do the factor tree. 20 is divisible by 2. 2 times 10. 2's prime, so I circle it. 10 is divisible by 2. 2 times 5. Both of those are prime, so I circle them. So this becomes 5 times, and 20 I'll write 5 first. So 5 times 2 times 2. Now this is a square root. Excuse me. My index is 2. Index is whatever number's in a slot. So I'm looking for a pair of somethings. Here's a pair of 5s, so they're going to come out in front as a single 5. Here's a pair of 2s. They're going to come out in front as a single 2. So this becomes 5 times 2. And there's nothing left inside the radicals, so we drop it. So 5 times 2 gives us 10. And that's our answer. Now let's take a look at our second problem. Then we've got square root of 3x squared times square root of 6x. And again, we want to multiply these. Well, since the indexes are the same, I can put them all underneath a single square root. I'll put the numbers next to each other, so 3 times 6, and I'll put the x's next to each other, so x squared and x. Well, 6 is a simple factor tree. It's just 2 times 3. So I can rewrite the 6 as 3 times 2. I'll flip them around. And x squared times x gives us x to the third. Now I want to simplify the x's, and I know we could do the x to the third pretty simple, but let's use our shortcut just to refresh our memory. We're going to take our power, which is 3, divide by our index, which is 2. Now the power is right here. The index is wherever number's in a slot right here. So 3 divided by 2 gives me 1 with a remainder of 1. Now this tells us how many we're going to have come out, and this tells us how many we're going to have stay in. Now going back to the numbers here, here's a pair of 3s. Looking for a pair of somethings. So a pair of 3 is going to come out in front. It's a single 3. And we said we're going to bring one x out. So we've got one x there. And inside we're left with a 2. And we say we're going to leave one x inside. So our answer is going to be 3x square root of 2x. Now they said to assume all variables are greater than or equal to 0. So it means we never have to worry about putting an absolute value anywhere. And that's our answer. Let's take a look at our next problem. We got negative 2 square root of 10 p squared q to the 5th times 5 square root of 8 p q to the second power. Now let me check everything. Negative 2, 10 p squared q to the 5th times 5, 8 p q squared. Okay. Now the indexes are the same, so we can multiply these radicals together. But let's multiply the numbers together first. Negative 2 times 5 is negative 10. Square root. I'll put the numbers next to each other. So I got 10 times 8. P squared p. Q to the 5th q squared. Okay. I don't want to actually multiply these together. I'll do the prime factorization of each one. So if I look at the factor tree, 10 is 2 times 5. Both of those are prime, so I circle them. Now 8 is 2 times 4. 2 is prime, so I circle it. And 4 is 2 times 2. Those are both prime, so I circle them. So I'm going to have 2 times 5, and then 3 2's. Now p squared times p, that means we got 3 p's. Q to the 5th times q squared means we got 7 q's. Okay, well, I don't got room probably to rewrite this, but we got square roots. We're looking for a pair of somethings. Here's a pair of 2's. They're going to come out in front as a single 2. And here's a 2, and here's a 2. So that's a pair of 2's. They're going to come out in front as a single 2. So we got negative 10 times 2 times 2. And we're left with a 5 inside. P to the 3rd, Q to the 7th. Well, 2 times 2 is 4, times negative 10 is negative 40. Let's look at our P's and Q's. P's. We're going to take our power, which is 3, divide by our index, which is 2. That gives us 1 with the remainder of 1. Now this is how many are going to come out. This is how many are going to stay in. Now our Q's. We're going to take our power, which is 7, divide by our index, which is 2. 7 divided by 2 is 3 with the remainder of 1. This is how many are going to come out. And this is how many are going to stay in. Okay, so we said we're going to have 1p come out. We said we're going to have 3 q's come out. So we've got q to the 3rd. Square root of 5. We got 1p left inside. And we got 1q left inside. And that's our answer. And let me double check all that. Okay, that looks right. Watching this silly TV while I'm doing this. Should be focused on working these problems, but let's see. 4. We got the 5th root of 36, a plus b to the 4th, times the 5th root of 54, a plus b to the 13th. I like this problem because it demonstrates you don't have to have just numbers or x's or y's. You can have anything to a power. Now these both have the same index, so I'm going to put them underneath a single radical. So we got 36 times 54, put the numbers together. And then we got a plus b to the 4th times a plus b to the 13th. Well, let's look at the prime factorization of these. For 36, 36 is divisible by 2. 2 times 18. 2 is prime, so we circle it. 18 is 2 times 9. 2 is prime, so we circle it. And 9 is 3 times 3. And those are prime, so we circle them. Now 54 is divisible by 2. 2 times 27. 2 is prime, so we circle it. 27 is not divisible by 2, so I'll go to my next prime, 3. It is divisible by 3. 3 times 9. 3 is prime, so we circle it. And 9 is 3 times 3. And those are both primes, so we circle it. So let's see what in the world we have. Okay. How many 2's do we got total? 1, 2, 3 2's. 3. And then how many 3's? We got 1, 2, 3, 4, 5 3's. 4, 5. Okay, now a plus b. We got 4 here, we got 13 of them, so we got 17 total. Okay, now our index is 5. The index is number in a slot right here, so we're looking for a set of 5 of something. Well, here's 5 3's, so those 5 3's are going to come out front as a single 3. And then we got the 5th root. Now, I just got 3 2's, so I can't do anything there. I'll go ahead and multiply them together. 2 times 2 times 2 is 8. A plus b to the 17th power. Well, let's figure out how many a plus b's we're going to have come out. So a plus b's. We're going to take our power, which is 17, divide by our index, which is 5. Again, take your power, divide by your index, number in a slot. And then this is old style division. 17 divided by 5 is 3 with the remainder of 2. So this is how many are going to come out. We're going to have 3 of them come out, and we'll have 2 of them stay in. So we're going to have 3a plus b to the third power, so we have 3 of them come out, and the fifth root of 8 times a plus b squared, because we had 2 of them stay in. And that's our answer. Let's take a look at this next problem. We got square root of 3 times square root of 7 minus 4 square root of 15. And want to multiply these together. Well, in this case, we have this radical right next to parentheses. That indicates we're going to use the distributive property. So we're going to take square root of 3 times square root of 7 and times negative 4 square root of 15. So we got square root of 3 times square root of 7 and square root of 3 times negative 4 square root of 15. Now, since these both have the same index, we can put them underneath a single radical. So this will be the square root of 3 times 7. Positive times negative is negative, and the 4 just stays out in front. And then square root of 3 times square root of 15 gives us square root of 3 times 15. Now, 3 and 7 are both prime. I can't do anything with that one. That's just square root of 21 minus 4. And then 3 times 15 is just 3 times 5. There's no use to do a factor tree. We only got 2 of them. And we always try to simplify our radical. We don't actually go through and multiply it directly unless we know it's not going to simplify, like 3 times 7. We're looking for a pair of somethings. Here's a pair of 3s. A pair of 3s is going to come out front as a single 3. So we've got square root of 21 minus 4 times 3, square root of 5. Which gives us square root of 21 minus 4 times 3 is 12, square root of 5. And that's our answer. Let me get a new page going here. And we'll look at the next problem. We've got square root of 2x times 7 plus square root of 40x. Well, we want to, we got this radical right next to parentheses, so we're going to take this and multiply it times everything inside. Multiply it times the 7 and times the square root of 40x. Distributive property. So we've got square root of 2x times 7 plus square root of 2x times the square root of 40x. Now, when you got a radical times a number, you just put the number in front of the radical. So we got 7 square root of 2x plus, and we'll put these under the same square root. So I got 2x times 40x. Now, the square root of 2x we can't do anything with, but this looks like something we can simplify. Let's look at the factor tree for 40. 40 is divisible by 2. 2 times 20. 2 is prime, so we circle it. 20 is divisible by 2. 2 times 10. 2 is prime, so we circle it. And 10 is 2 times 5. And both of those are prime, so we circle it. Now this 2 just carries down. Now 40 is 3 2's and 1 5. 3, 1, 5. And then I'll put these x's together, like that. Okay, well, we're dealing with a square root. The index is 2. There is no number in a slot here, so I know it's a square root. And by default, the index is 2, which means looking for pairs of something. Here's a pair of 2's. They're going to come out in front as a single 2. Here's a pair of 2's. They're going to come out in front as a single 2. And here's a pair of x's. They're going to come out in front as a single x. So we got 7 square root of 2x plus 2 times x. And then we're left with a 5 inside. Which gives us 7 square root of 2x plus 2 times 2 is 4x square root of 5. And that's our answer. Let's take a look at this one. We got square root of 5 plus 2 square root of 10 times 3 square root of 6 minus 5 square root of 2. Now notice we got two radicals here and two radicals here, so we have to multiply all this together, FOIL it, if you learned that technique. I'm going to use the line method I teach. So I'm going to take the square root of 5 here, my first radical, I'll multiply it times the first radical over here, and multiply it times the second radical. I'm also going to take this 2 square root of 10 and multiply it times the first radical over here and times the second radical. So let me just follow the line and see what to multiply together. I got square root of 5 times 3 square root of 6. Square root of 5 times negative 5 square root of 2. 2 square root of 10 times 3 square root of 6. And 2 square root of 10 times negative 5 square root of 2. Well, this gives us 3 square root of 5 times 6. Positive times a negative is negative, and then the 5 remains out in front. And then we got 5 times 2. Here we multiply what's out in front. 2 times 3 is 6. Square root of 10 times 6. Positive 2 times negative 5 is negative 10. Square root of 10 times 2. Now let me double check that. Okay. Now 6. If I do the prime factorization of it, that's 2 times 3. Now this one, these are both prime, and I don't got 2 of anything. Square roots, we're looking for a pair of something. So I'm going to multiply those together. 5 times 2 is 10. Plus 6. And these I can break down. 10 is 5 times 2. And 6 is 2 times 3. Minus 10. 10 I can break down. It's 5 times 2. And then this 2 carries down. Okay. These are square roots. We're looking for a pair of somethings. Here's a pair of 2's. A pair of 2's is going to come out in front as a single 2. And here's a pair of 2's. They're going to come out in front as a single 2. Now we don't got a pair of anythings here, so I go ahead and multiply them back through. 5 times 2 is 10, times 3 is 30. And then this carries down. Plus 6 times, again the pair of 2's came out as a single 2, and we're left with 5 times 3 inside, which is 15. Minus 10 times, again that pair of 2 came out as a single 2, and we're left with a 5 inside. Which gives us 3 square root of 30 minus 5 square root of 10 plus 6 times 2 is 12 square root of 15 minus 10 times 2 is 20 square root of 5. And that's our answer. And time to start a new page. We got square root of 2x minus square root of 3 squared. A lot of people miss this particular one, so I just want to refresh your memory on it. If you got this squared, you have to rewrite it this way. We write it as square root of 2x minus square root of 3 times square root of 2x minus square root of 3. The reason why you have to do that is you can't just square the square root of 2x and square the negative square root of 3. If everything inside is multiplication and division, then you can take everything to that power. But if you have a minus or plus in there, you have to write it this way. Then I'll multiply everything together, FOIL it if you like that technique. I'll take square root of 2x times square root of 2x and times the negative square root of 3. I'll take the negative square root of 3 times square root of 2x and times the negative square root of 3. So I got square root of 2x times square root of 2x. I'm just following the lines. Square root of 2x times negative square root of 3. Negative square root of 3 times square root of 2x. And negative square root of 3 times negative square root of 3. Now when your radicals are the same, see how this is square root of 2x and this is square root of 2x? Then that just gives you 2x. Now that only applies on square roots. Positive times a negative is negative, and then I'll put them underneath a single square root, so 2x times 3. Minus, and I'll put these under a single square root, so 2x times 3. Negative times a negative is positive, and square root of 3 times square root of 3 gives you 3. Remember, when the square roots are the same and you multiply them together, they just give you the 3. Minus 2x times 3 is 6x, minus square root of 6x plus 3. These radicals are the same, so I can combine the numbers that are in front of them. Here's an invisible 1, so -1. Here's an invisible 1, so -1. -1, -1 is -2, square root of 6x plus 3. And that's our answer. Last problem. Now this may look like the ones before it, but it's got a little trick to it I thought I'd mention. I got square root of 3a plus square root of 11b times square root of 3a minus square root of 11b. These are conjugates. Conjugate means your first parts are the same, square root of 3a, square root of 3a. Your last parts are the same, square root of 11b, square root of 11b. But the sign in the middle is different. Yeah, this is positive and this is a negative. When you have conjugates, all you have to do is multiply your first parts together and your last parts. So square root of 3a times square root of 3a gives you 3a. Positive times a negative is negative. Square root of 11b times square root of 11b is 11b. And that's your answer.